iFour Technolab Private Limited, an ISO 9001-2015 certified and leading sustainable IT service provider. Presents tutorial of smart contract using Solidity. The purpose of this course is to give you complete understanding and hands-on experience with smart contracting using Solidity for blockchain technology. In Chapter 11, Smart Contract covers an overview of smart contract and demystifies various smart contract jargons. We are going to discuss the following topics. What are smart contracts? How to create a smart contract? What are contracts? Money, property, share. Smart contracts are the best way to exchange money, property, shares, or anything of value without any issues. Middleman's role. This basically eliminates the middleman's role. Comparing the technology to a vending machine is the best way to go into the depth of smart contracts. You will visit the lawyer or notary if we go through the normal process, pay them the amount. You'll wait to get your documents after that, but if we go with the smart contracts, you'll just drop Bitcoin into the vending machine, also known as the ledger, and your bond or whatever drops into your account. Moreover, if we consider the traditional contract, there are rules and penalties for the same, but these are not stated in smart contracts, but obligations are attached to it automatically. How to create a smart contract. In this section, you will see how to create a contract in Parity, how to deploy contract in Parity, how to execute transaction and function of contract in Parity. Parity Ethereum supports state-oriented smart contract programming with the Ethereum blockchain's Solidity programming language. The wallet contains an integrated Solidity development environment allowing you to write, compile, and deploy contracts. Open Parity UI for writing the smart contract. When you open Parity UI, you will see various menus. From that menu, choose Develop Contract menu. After click on the Development Contract menu, you will see the screen which as you see watch the contract, develop and deploy. We will start with the Develop tab. So when you click on the Develop tab, you will see the Contract Development view which contains a contract code panel, left, and configuration parameters, right. To get started with your first contract, it's possible to load or import existing contracts. The Contract Development view contains a contract code panel, left, and configuration parameters, right. Let's create the invoice contract in the integrated Solidity development environment. Note that Pragma Solidity 0.4.24 requires a Solidity compiler version of 0.4.24 or higher, which can be selected on the right. Let's start with the practice of a smart contract. We will start with contract invoice management. So, first of all, we start our code by declaring the Pragma keyword with its version. The Pragma keyword can be used to enable certain compiler features or checks. A Pragma directive is always local to a source file, so you have to add the Pragma to all your files if you enable it in all of your projects. Source files can, and should, be annotated with a so-called version Pragma to reject being compiled with future compiler versions that might introduce incompatible changes. We try to keep such changes to an absolute minimum and especially introduce changes in a way that changes in semantics will also require changes in the syntax, but this is of course not always possible. Because of that, it is always a good idea to read through the changelog at least for releases that contain breaking changes. Those releases will always have versions of Form 0, by 0.0 or by 0.0.0. After declaring the Pragma keyword, now we'll start writing a contract name with using the contract keyword. Let's create a struct with name invoice. invoice having a member like an it from, to, subject, amount, status. So for status we need to create an NM with having a member like waiting, approved, rejected. Let's create it quick. Add one more member to struct created at Create an array of invoices with public keyword to add invoice details to the blockchain. Need to map address to and from, so for that we are creating two mappings with name incoming invoice and outgoing invoice. To create the first mapping for to user with name incoming invoice. Same we will create mapping from user with name outgoing invoice. Going invoice. Add an invoice to the blockchain, so let's create a method with name add invoice and parameter to, amount and subject, also with the public keyword. We don't use constant here, so it will use as a transaction. Invoice value to the invoice structure with all parameters like it, to, from, amount, subject. We will push this invoice structure to invoice array and get the index. Or the index to the id of the invoice structure. We will push the index to the incoming invoice of to address, also push index for outgoing invoice of from address. Purposes, we are using an event in Solidity. So let's create an event for adding an invoice with from and to a parameter. Call an event using a emit keyword. This function will add the invoice to the structure. How we will get the invoice details. So for that, we will create getInvoice method with a parameter index that will returns invoice details. Here you can see we are using constant because it uses as a function and not as a transaction. As a transaction. The index to the invoice array to get the invoice details. Learn all properties of the invoice. How we will get the incoming invoice details. For that, we will create a method with name getIncomingInvoice with parameter underscore index of user address. Index of an array after passing address and underscore index to incoming invoice mapping. Plus the index to the invoice array to get the invoice details. Learn all properties of the invoice. Do with outgoing invoices, but in the outgoing invoice method we will pass from address instead of to. Now, we finally want to deploy our contract, so first select Solidity compiler version with 0.4.24. compile button after completion of compilation that will generate AB bytecode metadata. Button. You have to specify the contract name, contract description, from an account that you want to deploy, then click on Create button. To approve the transaction request. For that, you have to select the local key, then enter the account password, then click on Confirm the request. Successfully deployed. You will see that the transaction mined. On the Home button and go to TXQ Viewer menu. You will find your transaction. Will be available in your Parity. Once deployed and mined, and it will allow basic interaction. To view the contract, you have to go watch the contract. You will find your contract in list. Click on your contract. Executes button. From an address that you want to do the transaction. Transactions display, so select functions that you want to execute. From the listed function, selected invoice contract function, enter parameters. Contract function, enter parameters like address, amount and subject, and then click on Post Transaction. Step. You need to select a local key and insert a password for executing the transaction. After inserting password, submit your transaction. See the event on the event section named Add Invoice Event. Invoice details with various methods which we have created, like get invoice, get incoming invoice, get outgoing invoice, outgoing invoice. Pass parameters like an index for get invoice function. Outgoing invoice index and from address parameter. Create another invoice with two separate from and to account. An invoice with one index. The index into the parameter for get incoming invoice function. Click on any of the method and press Query button. You will find all the information. Detail, in which you will find contract detail and contract ABI. That's it in this video. Thank you for watching and stay tuned for our next video.